Welcome back to the Cave of Science with the Running Scientist. Excuse me. And we're looking at mole ratios using the before, change, and after method. This is a little bit different than using dimensional analysis. I guess I'll call this more of a tabular method of doing stoichiometry in chemistry problems. So let's just jump right in. So we'll do the first one here. It says lead will acid produce lead-2 chloride and hydrogen gas. How many moles of hydrochloric acid are needed to completely react with 4 moles of lead? Well, the first thing you always need to have is a balanced equation. So we have lead, so that's Pb, and reacts with HCl to produce lead-2 chloride and hydrogen gas. Alright, so let's go ahead and take a look at this. If you recall from your charges, if anything's a free element, it has a charge of 0. So these two are okay. The charge on hydrogen's a positive 1, charge on chlorine's a minus 1, so those two are balanced for charges. And we're looking at lead chloride, and we know it's lead with Roman numeral 2, so it has a charge of a positive 2, and we know chlorine has a charge of a minus 1. So we can do the crisscross, so we get PbCl2. So now we have it balanced for charges. We need to go back and balance coefficients for the number of atoms. Well, this one's pretty straightforward. We got 2 chlorine, we only got 1. We got 2 hydrogens, we only got 1. So this one's fairly simple. We can go ahead and put a 2 in front of the HCl. 1 lead, 2 hydrogen, 2 chlorine, and 1 times 2 is 2 chlorine. So we're looking pretty good there. So what this is really saying with the coefficients, 1 mole of lead reacts with 2 moles of hydrochloric acid, and it will give you 1 mole of lead-2 chloride plus 1 mole of hydrogen gas. Well, the whole idea with using the before, change, and after is go ahead and let's put in some values here. Now we're saying how many moles of hydrochloric acid are needed to completely react with 4 moles of lead. Well, we've got 4 moles of lead. Now the before, there's no reaction. So our products are 0 and 0, because this is the before part. Now we want to know how many moles of hydrochloric acid are needed to react. So we're assuming here that hydrochloric acid is going to be in excess. And to signify that, we'll put in excess on there. Alright, so now we want to know the change. Well, our ratio of coefficients in the balanced formula is 1 mole to 2 to 1 to 1. Well, we've got 4 moles. So really, as we're looking at this, if we've got 4 moles, we want to know what the other molar amounts are going to be. Excuse me. So if before we're at 4, the change, we want to react. So this is really, the change is really the reaction. So we are going to use up 4 moles of lead because we want it to completely react. And to react this 4 moles of lead, it's going to take 8 moles of hydrochloric acid because it's a 1 to 2. If 1 mole is to 4, therefore we know that this is going to be twice the amount of this one. And we can go ahead and carry it out through the rest of this. If this is 1, this is 2, this is a coefficient of 1, 1. So it's 4 to 8 to 4 to 4. So that is our change. We are using all the lead. It takes 8 moles of hydrochloric acid, which is really in excess, to give us 4 moles of lead chloride and 4 moles of hydrogen gas. So the after, So fluor minus fluor, we used up all the lead. This is really an excess. Yeah, we needed 8 moles, but we've got plenty. So we can still say this is an excess. And we produced 4 moles of lead chloride and 4 moles of hydrogen gas. So again, the ratios remain the same. 1 to 2 to 1 to 1, 4 to 8 to 4 to 4. Again, we're looking at, because we had 4 moles of lead. All right, let's look at another problem doing the same thing. And this one we happen to have balanced already, so pretty straightforward here. How many moles of hydrogen gas will be produced if 2.5 moles of calcium hydride react to the following equation? All right, so we want to know how many moles of hydrogen gas will be produced. We've got 2.5 moles of calcium hydroxide. And again, typically when you have a reaction, something's going to be in excess. Well, if we're given the amount of calcium hydroxide, the water is probably going to be in excess. So we're going to say we got an excess amount of water. And we are going to, again, before the reaction takes place, we have no products. So it's kind of a key thing to remember. If you're not given any, if you're not starting with any products, and you're only given a reactant, well, you've got no products at the beginning. The reaction didn't take place. All right. So we want to know how many moles of hydrogen gas if we got 2.5 moles of calcium hydride. Well, once the reaction starts, we are going to use these 2.5 moles. And again, the relationship is 1 mole of this to 2 moles of that. Well, if we've got 2.5, this is going to end up being, we're going to end up using 5 moles of water. And this is 1 to 1, so this is 2.5 to 2.5. And this is 1 to 2, so 2 times 2.5 is going to be 5.0. So looking at the reaction, again, this is from the balanced equation. Well, we used up all the calcium hydroxide, so we've got nothing there. This is an excess. We used up 5 moles, but we still have plenty of water left over, so this is our excess. The calcium hydroxide, we made 2.5 moles, and the hydrogen gas, we made 5.0. So these first two problems have been pretty nice because of whatever we've been given, its coefficient has been 1. So that makes the work a little bit easier. All right, let's look at problem number 3 here. And let me move this up a little bit so you can look at it. I guess that'll work there. All right. How many moles of water will be produced? Let me get this out of here for you. Get that out of the way. How many moles of water will be produced if 0.45 moles of oxygen reacts according to the following equation? Looks like we got a balanced equation. This is a complete combustion reaction. So let's go to the before. We've got 0.45 moles of oxygen, so we know we've got this much oxygen. We know we don't have any products. And we want to know how many moles of water, let's see, how many moles of water would be produced. So we don't know what this is right offhand of the C6H6. All right. Notice the other ones, whatever we were given, the coefficient was 1. So we've got to find some type of relationship. So we know from the balanced equation, 2 moles react with 15 to give you 12 and 6. Well, we need to see what 1 mole is worth. So let's take this right here. We know it's going to be 15 to 0.45, and we want to know what 1 mole is worth. So that's going to be 1 to x. Now you can do this little part off to the side somewhere. Again, cross multiply and divide. So 15x equals 0.45. X equals 0.03. So we were given 0.45, but that's really 15 moles. So we want to see what the value of just 1 mole is in the balanced equation. So we can do this, and it comes out to be 0.03. So from there, we can go ahead and do the rest of this. All right, so the before, we still got to figure out of C6H6. So we have 2 to 15, and we know 15 is 0.45, and we know one of these is 0.03. So let's just multiply that by 2. So 0.06. So we have that. And again, we use just this little relationship here to figure out what 1 mole is worth. Because we know 15 moles is 0.45. What is 1 mole worth? Or what's the value or the amount of 1 mole? All right, from here we can go ahead and do the change. And again, O2 typically is going to be in excess. You can definitely see we got a whole bunch of this, a whole bunch of O2 here. So we're going to use up 0.06. We're going to use up 0.05, or let's see, 0.45. And we're going to produce 12 times this amount. Oops, let me get it back in the picture here. We're going to produce 12 times this amount, which is 0.36. And then we're going to produce 6 times this amount, which is 0.18. Well, we're going to use up all the C6H6, so we're going to have nothing. O2 is, again, going to be in excess. So we can put down this as excess. Yeah, we used up 0.45, but we got plenty of it around, so it's going to be the excess. And we produced 0.36 moles of carbon dioxide and 0.18 moles, and I guess I should put the zeros there, of water. And again, it's this relationship of the given. You got to find out what 1 mole is worth. So this is the before, change, and after method. It's again, I'm going to call it a tabular way of looking at stoichiometry instead of doing the typical dimensional analysis. So until next time, we'll catch you later.